Hello. Today we're going to look at two techniques that you can use to clean up your update loop, make your code easier to read, easier to debug, and harder for you to add new bugs in, easier to maintain. So let's take a look at a messy update loop as just a place to get us started and sort of think, why is this so messy? Why is this so hard to work with? So this is a real project, although I've messed up some of my own code for the sake of demonstration, made it look more like my students' code. Yes, I'm calling you out. Let's take a look at what's going on. We have some logic to do with hovering over tiles, and we have some logic to do when you click the mouse button. We had to do a bunch of different checks. We had an if, and then an if, and then an if, and then an if. And one of these is an else statement, and another one is an else statement somewhere else. So when we're down here and we're trying to think, okay, when is this code getting run? It's, it's difficult, it's tricky, it's really messy. So how are some ways we can clean all this up? The first technique is early exits. So early exits. So we're actually going to run this code, and we're in debug mode, and we have some a breakpoint here. Let me put a breakpoint there too. And that code is going to, so we're going to step through line by line at what's happening. So let's start. I'm just calling my example functions in order. So we hit the first breakpoint, random true or false. We have some condition. When it's true, we will return this value, right? This is a function returns a Boolean. So wherever this code is, that is going to turn into some property. Right here, we're ignoring the return value. So I probably should have typed something like, something like that. Oops. Some variable here that we're going to store as this property. But let's keep stepping through. And it's a random value. It was true. And none of the rest of this code is going to run. We're going to jump to the end of the if statement and jump out of the boom. Now we're down here at the end of the function after the if statement. And then we jump out and we go to the next one. So here we're at this breakpoint. And this one is structured a little bit differently. So the first code, the first function had two branches, and one of them exited and the other one exited. This one uses the pattern in contrast to that one of an early exit. So we have inside of this if statement some return statement. And if whatever's here is true, then none of the rest of this code will run, right? It's not like we're skipping a branch. It's more like we're walking down a hallway and there are trapdoors at different states, and whether or not we fall through them or we keep walking down the hallway. So let's go through this function and let's see. And turns out we're not in the gameplay state, so our input should not be active. So we'll return false, jump to the end, jump out. So let's go into our next function. So this is a normal function, just to sort of give you as an example to compare. We have some if statement, and then we'll run a debug, some logic. So that code happens or doesn't happen for whatever reason, and we're done. So to compare the normal if statement, where we put our code inside of the curly braces, with an inverted if statement. And an inverted if statement, we put our code after the curly braces, and then we flip the if statement around, and then inside of them, we quit. One thing to note, you'll notice that this is a void function, a function with a return type of void, which isn't a type, so it doesn't return anything. So the return statement has no value after it. We're not returning some number or some Boolean. We're returning void. We're returning nothing. And yes, we can do that. It will end the function. It will stop running the function right then and there, and it will exit it. We flip the if statement around, and then inside of them, we quit. So here, if this same value is up here was true or was false, or if this was true, then the opposite of it would be false, and then we would skip exiting, and then our code would run. And what this early exit or inverted if pattern does is it prevents us from having that if chain of you're indenting your code every time, and now your code's starting halfway across the screen. It saves us from that kind of mess, right? If you remember this example here, all of these, right? Then somewhere down here, all of these, right? If we use that other pattern where we can do that because this code gets to the end of the function, we can do that up here, actually. We can save ourselves. There we go. And then we return. And that should have auto-indented. And I'll have one extra curly brace to get rid of. Yeah. And then we can shift tab. And now I've changed this update code. I've made it a little bit cleaner, sort of, where if input isn't enabled, then none of this code should happen. And I'm in an input script, so that's maybe fine. So it'll, if this code's running, we get to here, we're just going to skip all this, right? Which is exactly what we were doing before when it was, inside of the if statement. But it's just one less indent, right? So it doesn't change the logic of the code. Or that's the idea. It can affect your functions though. So early exits and inverted ifs, that's trick number one. But this can mess up our functions because maybe there's some logic that we want to have happen in our update loop. We want to check all this hover code. We can't quit this early. We can't put a return statement up here because then this selection code will never happen and we need that code to happen. So that's where we get to the way to clean it up, trick number two. And trick number two isn't really a trick. It's just use functions. Stop putting all of your code in one function and what we call extracting a method. Pull it out, wrap it up in a function with a name, and then clean up your update loop that way. So here's an example of what an update loop that's messy might look like. We have some if statements and some checks, and then our code that runs. And then another set of unrelated if statements and checks and some other code that runs. So to clean it up, we'll take all of this logic and we'll put it in one function. We'll take all this logic and we'll put it in another function. And now our update loop looks like this. It looks just like a list of function calls. And then all of that logic from before. And, we don't even need to write comments because we can give it a nice clear function name that is a label that tells us what this function does. But also the second thing it does is it lets us use that early return inverted if pattern and clean our code up, maybe even more. Now, whether or not this actually cleans your code up sort of depends on your project. It is a little bit harder to read an inverted if than it is to read a regular if, because you have to remember that what you care about is the opposite for it to keep going. So it's a little bit harder to read. In a case that if it was literally this code, I would probably just do this because this seems easier to read. But there are other situations in which case this one will be easier to read. So and then if this was in the other order, or if some this was happening first, really easy to reorder things and maybe fix race condition bugs. But I can early exit out of this function without messing up this function, right? Because they're unrelated. So let's take a look at our messy example that I had open from before. And then let's look at what I did. I rewrote that same function here. I didn't. This is the function from the actual project that I used as a starting point for this video. I wrote the messy version of it. I also wrote this version of it from before. So here's the actual real project update loop that I wrote, where I have everything wrapped up inside of an if statement. Here it does not make sense to use an inverted if statement because it's just so simple and easy to read. And then I have my hover logic inside of a function called hover tick and my selection logic inside of a function called select tick. And then I got all my if statements and all my complexities, but I got one case where I can jump out of here instead of an if else. So it's a little bit not quite so messy. And then for hovering, there's no returns, but it's fine. So that is pretty good, pretty easy to read. The advantages of extracting all your methods this way are numerous. One, again, the labels act sort of like comments where I can just read it and I know what it's doing. It's easier to understand. It's easier to comment out entire sections of my logic without having to think too much about it. It's easier to set breakpoints where I can jump in and debug. And when I hit an error and I'm inside of my select method, it probably has to do with the select function. And if I hit an error and I'm in the hover method, it probably has to do with that hover function. But if I'm in one massive update loop that has all these 4, 5, 6, 7 different pieces of logic going on, I hit a bug and it's like that bug was on line 5061 or whatever. you know, it might have been something up above or some other variable, or who knows, we'd have to debug it. Harder to debug. More small functions that are easier to debug. Anyway, that's all I got for this video. I hope you found it useful or helpful. I hope you'll consider making your update loops look like just a list of function calls and going from there and helping that lead the way. To be somewhat honest, if you have a lot of function calls here in an update loop, the question sort of should arise of like, how many different things is this one component trying to do? And should you consider splitting it into multiple components on the one game object? So keep that in mind as well. And that can just have its own update loop and do whatever. So we could have maybe a hover and a click components. Doesn't make sense here, but in other hypotheticals it might. Anyway, okay, now that's all I got. I'm leaving now. Goodbye. Hope you enjoyed.